Okay. Hello, hello. Okay. I think I'm going to start. Let me just confirm this is working. Yep. Okay. Hi everyone. This is supposed to be our virtual meetup number one. First virtual meetup. Unfortunately, things didn't go as according to plan, and so I have decided to just come on here on Facebook Live, and because I promised to do this, to do this presentation or this security talk, so I'm going to do this, and so we could have like a recorded session, and anyone interested in going through the content can do that later whenever they come on Facebook. So initially, we also had planned for two people to run this session. Unfortunately, the host is busy, so I am going to be the only one um, doing the presentation or talking about the cybersecurity topic that I'll be talking about today. Okay, so without further ado, I should get right into it. So today's topic is insecure deserialization, which is one of the OWASP top 10 vulnerabilities. And I've decided to talk about this topic after recently attending a cybersecurity virtual meetup group. So they had this session, and it's called Silicon Valley Cybersecurity Group. So they had this session, and someone was presenting on this topic, and this guy was obviously a researcher. So he was like showing things he did, things he worked on. So he went in detail, but what I'm going to do, I'm just going to be doing an introduction on insecure deserialization, and I'll try to do this as quickly as possible. But yeah, that's just how I decided, and I chose the topic to talk about in this session. So yeah, that's just that. All right, so agenda, I would first of all try to briefly define what OWASP top 10 is, and then I will try to also, or we'll have a look and try to understand what insecure deserialization means, and then followed by some prevention and remediation tips and some examples, and finally, if possible, some real world incidents as well. Okay, first of all, what is OWASP? Or the acronym or initials OWSP stands for Open Web Application Security Project. And this is a project that consists of people from all around the world that contributes to the work they do in terms of code or the documentation that they do. They have some very good documentation on their website. So anyone in this field should totally go there and check it out. And the OWASP Top 10 is one of the very successful projects that has been done so far by this group of people, this group of volunteers. Okay, the OWASP Top 10 Web Application Security Vulnerabilities, or list, as the name implies there, consists of the 10 security risk or vulnerabilities that are deemed of high that are like deemed high or have high critical or severity or high risk. They're just high risk vulnerabilities. So at the very first on the list is injection or SQL injection, as we know. And one we are talking about today is the eighth on the list, insecure deserialization. And then there's also the other one that's also known by a lot of people, XSS or cross-site script. Is, as you can see, is just before the insecure deserialization. So I am going to be talking about this topic, insecure deserialization, but it's also important to, in being in this field, to try to understand the other vulnerabilities as well. So what is insecure deserialization? I think maybe the best way to do it is to first of all understand what serialization means, followed by deserialization. And so, according to the definition, the serialization is turning some object into data format that can be easily stored or sent in communication. Example, JSON or XML. And there's a diagram on the right. I believe that does a good job in explaining. So I'll try to explain it this way. We know of object-oriented programming languages like Java and Python, right? So I'm going to try to use an object as an example. So let's use a user object, and a user would have attributes or properties like user ID or username, date of birth or width or height, things like that. Now this property can be converted or turned into a byte stream, which can be in a form of JSON or XML, for storage. So they can be stored either as a file or temporarily in memory or in a database, or can be sent in communication or sent over the network. That process is called serialization. Now, the opposite of that process is deserialization. So deserialization is taking that byte stream, converting it back into its original format, which would be in this case a user object, which can now be processed or executed by the programming language, or the computer can understand and then run the program, right? Okay, so insecure deserialization now is just the deserialization process being done insecurely. So there's no things like validation of data, sanitization, things like that. It's not be taken into consideration. So at this stage, if you're not yet clear about what I'm saying, or if what I'm saying is not clear, don't worry. We'll later on. I'll go through some examples. Hopefully, that will become a bit more clearer. So let's just proceed from now. So before I touch on some examples, let's just go through some prevention remediation tips here. So first of all, it's just advisable not to serialize, because if you're going to serialize, then you will have to deserialize, and then that might put you at risk. But if it's like absolutely necessary, then before, when you're doing that, just take into consideration security mechanisms, or things like ensuring this integrity checks being performed, or digitally sign the values when setting and verifying signatures when submitted, or running deserialization code in a low privilege environment, so that when there is an exploit, the live production environment it's not affected. And then there's this thing about WAF, or web application firewalls. WAF don't really do a good job when it comes to detecting exploit attempts. As far as insecure deserialization is concerned. So that's why it's very important to ensure that if you're going to work on applications, and those applications will have to serialize data at some stage, then try to make sure that you take into consideration the security, and just implement the best security best practices to prevent putting you at risk. Okay, now I am going to touch on some examples. So first of all, first example is in Python, and I've decided to use Python because I think Python would be easy to understand. And also in Python, there's a module that has this vulnerability. It's called pickle. So on the left-hand side, under insecure deserialization, we are going to import pickle. And then there's a class example there. Below that, there's a reduce function. That function is called when serialization takes place, or when an object is serialized. And then at the client side code, there is, well, we're going to run the command who am I. The output of who am I, we're going to serialize that. And by using pick_dumps, that's a function where we use pick_dumps to serialize the output of who am I command, and then print serialization done. Now at the server side code at the bottom, we will, deserialization takes place at the server end, right? So what we are doing here, we're going to deserialize the code. So at the server end, we will print that's a mistake there. It's supposed to be deserialization in progress. And then we will deserialize the object by using pickle.loads, and then we will print deserialization done. Now on the right hand side, let's just say that on the left hand side, there's a vulnerability, and now we want to secure that, make sure that if that's an app that's using that this code in the app, we want to make sure that it's not vulnerable, or it's not at risk, or we want to secure it. So what we are going to do on the right hand side now, you see that everything else is the same. The only thing that's different now is we are implementing a new class. It's called class Mac. Now at the very top, just below where we imported the modules. Now at the bottom of that, or just below that, class Mac, Mac stands for message authentication code. And so this is a cryptographic technique that we are using. So basically what's going to happen, as soon as the connection request, so HTTP request, is received from the client, what's going to happen is the server compares. So at the very bottom, where there is server side code, you see that there's like a condition there. If the condition is met, the server will print deserialization. It will deserialize the object, and it will print deserialization done. Or else it will reject, and it will print deserialization failed and data altered. So I'll just quickly go to code, to this VM here. And so what I have talked about already, this is the code. So what we are doing here, I'll just quickly go through this again. So we're importing pickle. Pickle in Python has this vulnerability, and then we have a class example, and then a function reduce that's called when an object is serialized. Now we have the client side code. This is what will happen at the client side, right? So we are running who am I command here, and now we're serializing this object by using pickle.dumps, and then we print serialization done. Now on the server side, where the deserialization will take place, we will print deserialization in progress. Pickle.loads, we will deserialize the object here, and then we will print deserialization done. So I'll just run this code, and the output is this, just like what we expected. So we have deserialization done, excuse me, and deserialization, sorry, let me say it again, serialization done, and then we have deserialization in progress, and then we have the output of who am I command is this. It's obviously in Windows, we know if you type in the command in the terminal, who am I, it gives you the computer name and the username. And since I've been logged on here as admin, the username is admin. And then deserializing, after deserializing the object, it prints out deserialization done. Now let's say that there's an attacker who has intercepted the code, gotten hold of the code somehow, and wants to manipulate. So because this system already has this vulnerability, now manipulating the code, it's the attacker. Instead of running who am I, the attacker would probably say type in system info and run this code, and we'll see what happens. So I'm just going to run it now. we can see that now the attacker has a hold of this information. So he or she now know the host name, the OS name, the OS version, the build type, all this information like BIOS version, even information like the latest hotfixes that was installed on this machine. So now the attacker has like an idea and probably could like engineer or plan his attack around this information that he or she now have. So let's say that we want to prevent that from happening. So here now in Python, we've already talked about this class MAC, which stands for message authentication code, which is an encryption technique. So we are going to implement this technique now. And now at the bottom, what's going to happen is as soon as the server receives this request, it will have a look at this condition and see if it matches, if the client has the same key, right? If it doesn't, it will reject. It will print out deserialization failed and data altered. If it does, then it'll proceed to deserializing the object, and it will print all this deserialization in progress and deserialization done after the process is complete. So if we run this code, we'll also see that that is as expected, right? So what we didn't touch here already is this part. This is where the attacker is. Let's say that's the client, then it's the server. And maybe there could be like a man-in-the-middle attack. So now the attacker tried to manipulate this data. So instead of that, who am I? Try to get some information at the back end of the target machine. And so they use the system info. But then the thing here is this person now doesn't have, this client now doesn't have the key. So doesn't have the MAC key. And so when then the server receives this request, compares that the condition didn't match, and so the server drops, or rejects the connection, and that's what we got as a result. Deserialization failed, and it printed out data altered. All right, so let's just go back. Let's go back to the slides. Now that's the first example. Now we have another example in PHP. Now, PHP app as a user object, which is serialized and stored in a cookie. Now, the thing about PHP is serialized data is human readable. So if you look at it, like you can tell that there's the role, right? So there's a role as an employee. Now, what if the attacker might say, what if I modify this, try to put in admin to get like escalate privilege at the back end or something like that? So now the attacker would modify that, put that admin instead of employee, so manipulates the data this way. And now when the application deserializes the cookie without verifying integrity, that could lead to administrative rights being granted. As a result, the attacker would now have admin rights, and so this can then lead to things like RC or remote code execution. So we'll just quickly go to this example as well on this one. Let's go here. All right, so I have the code for this one. So in my machine, so I'll just copy this, paste that in here. And so what's happening here is that we have a user object, right? And this user object has attributes, properties, username, and status, and we want to serialize that. And in PHP, if we want to serialize, we use the command serialize, and we pass in the object. So if I run this, now this is the string representation of the object, the serialized object. And so now let's say that the attacker has a hold of this information, and because you can read it, it's user, it's not encrypted or anything like that. So the user might say, okay, maybe let me try this, get a hold of this information. So I'll just copy the other code. Now it's got a hold of this information, so the serialized data, and changes that. So instead of user, and in PHP to unserialize, to deserialize, use the command unserialize. So now changing that to admin, and if we run this code, we have to, oops, sorry, I have to change the number of characters as well. Now this object has the admin privilege. So this now, this can then lead to other things like remote code executions and things like that. So let's just go back. I'll just go back quickly to presentation slide. So that's the example in PHP. And yeah, before that, let me just go to this another thing that I want to mention as well. There are things like, I believe this is called, or pronounced as YSO serial. This is Java object deserialization tool. So there are many of these researchers that have mentioned that this tool is like a script kiddie tool. So meaning that people who use it don't necessarily have to know code. They don't need to know, but like the difficult part that most programmers need to know to write code. These are to come up with apps and tools like this. It's just like it's as simple as installing it, running it, performing your exploit. That's why when you're dealing with code that would at some stage you would have to do serializing or deserializing of data, just take into consideration that things like this. Okay, so going back to our slide, now we want to talk about some incidents that happened. And in 2017, so we know of this big Equifax hack, right? And that happened at this American credit bureau company. And when we talk about credit bureau, you think about things like people's credit records. And so this is a free source from Wikipedia that I took. So if you're interested, you can go there and have a look. I have put the link down at the bottom. So according to stats there on Wikipedia, about, you talk about millions of people affected. So they had like over 100 million Americans, over 15 million British citizens, and 19,000 Canadians. And even to this day, the company is still paying or losing money by paying compensation to these people in like certain funds and credit monitoring, things like that. But what actually happened here was the company was using a third-party software, and that software company had released a patch for a critical vulnerability that was found in the system. So I'm not too sure what really happened there, but people probably were working at the time when the attack happened. I don't know if they were too busy, or maybe they just thought that it's just a minor thing and overlooked it, or but then the thing was, these bad guys, it's probably these bad guys know that this company uses this software. So now they took advantage of that. They hacked the system, and the rest of the story we all know. So talking about this hack that happened in 2017, and so we might say that, okay, it's like 2, 3 years, 4 years ago from now, right? I mean, 4 years ago. So people should be maybe educated about these things, and maybe that shouldn't happen again. Well, if you're thinking like that, I hate to break your bubble, but let me just bring your attention back to 2021, the Exchange server hack, which is also a big one, and it's attributed to the afternoon APT or cybersecurity espionage group with alleged ties to the Chinese government. And Well, apparently they deny that. So who really knows what's going on, right? But why I am bringing this up and using this as an example is, let's go to this Microsoft website. So this is where they list down details of this attack, the Exchange Server zero-day exploits. And if you look down here, Microsoft has detected multiple zero-day exploits being used to. So they stated that there were multiple zero-day exploits being used to attack on-premise versions of Microsoft Exchange Server. At the bottom, there's a bit about what this group is, like a bit of background information about the FDR group, hacking group, and then there's this technical detail section. This is where they list all the CVs, the common vulnerabilities and exposures. Now, the first CV is related to the server-side request forgery, or SSRF. The second CV is an insecure deserialization vulnerability. So there you go. That is still a problem, obviously. Okay, so I think that will bring me to the end of the presentation. But before I finish, I'd like to just touch on is there something interesting that some researchers talked about that I just want to maybe bring to our attention and discuss a little bit about. So this is a report from this group. This is the company Palo Alto Networks, and they have the security researchers or research group called Cortex Expanse. And they had this is a recent report, and they talked about something I think is quite interesting and maybe we should also touch on. It's called mean time to inventory, or MTTI. The definition, as I've written out there in yellow, MTTI, or mean time to inventory, refers to the startling speed with which the bad guys have begun scanning for vulnerabilities after the first public announcement. So the very first announcement, as soon as the CV is made known to the public, it's very quick how they do it. So what some other researchers did analysis based on these reports. So there's someone that I thought I should probably bring up as well. His name is Steve Gibson. Steve Gibson is a security researcher, and it's quite known in the industry. He's done a lot of work in security. He's a software engineer as well. So he did his analysis based on this report. So I'm just gonna go quickly there. This is what he wrote based on the mean time inventory. This term, this is a new term, but it's becoming quite known now and being used more often now in the industry. Mean time to inventory. So according to the researcher, security researcher Steve Gibson, the bad guys have databases indexed by port. So imagine like they have scanned the network far and wide, globally, all the big companies in the world, and they know what services are running, what interfaces are facing the internet by ports and by ports that are open, and what's accepting connections, things like that. So they have all this information on the dark web somewhere, on a database, and they sell this information to each other or whatever they do. So what happens is, as soon as a vulnerability is made known to the public, he went on to, if you have a look at this report, he went on to try to describe it as in a blink of an eye. It happens just like that. They're very quick. So the Cortex Expanse security research group mentioned that. So they were monitoring. So it's their job, right? So they were like already monitoring when the hack happened, the Exchange Server hacks. So what happened there was, as soon as the vulnerability was made known, it took them. They detected the first the very first vulnerability scan, which is obviously coming from the bad guys, happen within no more than 5 minutes. So it's really quick, right? Now, further below here, Steve Gibson went on to mention that, I mean, that means that attackers would also need to write and deploy custom code within like 15 minutes in order to scan for not yet pets code. So they are, it's really, I think it really adds like a new perspective to what we are doing as security defenders, right? We either like improve or we fall behind. So we have now this race that's going on between the good and the bad guys. And I guess what I'm trying to say, why sharing this is so that we understand the importance of sharing information. And if like people like that, these researchers in this research, if they didn't think of sharing in the first place, like would have known that this is what's happening, right? That's why, like, it's very important that we come on board and we try to be involved. Come feel like you are a available member of the group. Try to participate. You're coming from you're coming with years of experience, and so you would know a lot about what you do. Feel free to share. Feel like you're valued in the community. Share if you have researchers or anything at all. Like we could talk about things like attack vectors, and we could talk about current trends of what the bad guys are doing as we are updated with what's going on, because it's working alone. It's okay, but there are limitations to it. But in a group, I believe that we can do a lot more than one person can do, right? So I think that did bring me to the end of the security talk for today. So I'll just go with the slide. Yeah, so if anyone have any question, feel free, just maybe put in the comment section. I'll have a look and I'll later try to respond if I can. Otherwise, I think that's the end, and that's the end of the security talk for this month. And I look forward to seeing you all. Hopefully next month when we meet and we listen to our two other friends. The other one will be presenting in June and the other one following that in August. So hopefully I can meet with some of you by then, or when we meet up for that. So thank you all, and thank you for listening. And yeah, I think that's it. So goodbye for now. Have a good weekend and have a wonderful, great week. Goodbye. I'll just end the session. I'll just end this live, Facebook Live with MI.